Hello, my name is Jason Papucci, and this is my final project for the Infotech and Data Analytics class. As a part of the pre-work, I read through the different disciplines on the COVID-19 website, and what became very clear to me is that I became genuinely interested in how COVID-19 spread throughout the United States. What were some of the indicators? What slowed it? What didn't work? Maybe if there were hotspots. And so this is the journey on how I tracked the spread of COVID-19 and what questions and hypotheses I wanted to test as a result of it. So my first step was to determine how did it spread throughout the United States. And I used the data that was provided on the website. And as you can see here, this is a map showing that Washington State was the first case on January 22nd, 2020. The first reported case on January 22nd, 2020. Shortly after, on 2/1, there were 4 more states that reported their first case: California, Arizona, Illinois, Massachusetts. California reported 3 on 2/1. That was their first report date. And so this depicts how it started to spread. Very interestingly, as I started to track the spread from these initial states to the rest of the country, you can start to see there is a 28-day lag from 2/1 to 2/29 before any new cases start to show up or get reported. And that is intriguing to me. And so a question that I needed to answer, at least try to find if there were any leading indicators, was why was there a 28-day lag before new states reported cases of COVID-19? It is very curious, as you can see here, why nothing was reported. So it's definitely going to be something I definitely wanted to look into. Next, I wanted to characterize, once those states started to report, from 3/1 and forward, how quickly and what did that exponential rate look like? And what I needed to characterize was, when was the first case reported by each state? I used this bar chart in an interesting way, where the vertical axis is date reported, and it is progressing upward. And so you can see here's the first case for Arizona, Illinois, California, Massachusetts, and Washington. So those were the very first ones that we discussed. And then that 28-day lag is shown here. And then, like wildfire, all of the other states started to report their first case, which just further characterizes, and it's a good visualization to show in a very short time period from 3/1 to 3/15, and by 3/21, every state had reported. You can see up here, West Virginia was the last state to report a case of COVID-19. So now, going through these visualizations, I now have a good understanding of how it progressed. Started in Washington, first 4 states were, or I should say first 5 states were early on to report cases, a long lag, and then a boom of cases reported all within roughly 2 weeks. So this leads to my hypotheses. Did the start date of the government stay-at-home orders affect spread of COVID-19? This was something that when I was going through the disciplines, I was reading through government files, something that was relevant even in my workplace. Uh, Very curious. Did this have an impact on the 28-day lag, etc.? And so I wanted to characterize that. Does a state's population have an impact? When I was looking at it, it looked like the larger states in the country had more impact. So I wanted to characterize that. And finally, did the 28-day lag come from improper reporting or inaccurate reporting of flu A and flu B? Again, something relevant at my workplace. As I went through this, I started to connect some dots that, we had a high absenteeism rate in that time period. And it was curious to see that there was a 28-day lag of COVID-19 cases in that time period. So that was something else I wanted to characterize. So first, what were the impacts due to government orders? To do this, I had to do some data mining. I found on the internet I was able to find the start dates for all of the different government orders for each state. The challenge was I needed to figure out how to show this in a visualization. I came up with a pretty unique way. I used a small multiple chart showing the start date of the government mandate orders, since what I realized is there were multiple states that started on the same start date, and of course sorted by date. And I simply showed each small multiple chart shows the progression of cases per state. Unfortunately, not a lot of correlation. You can see no matter when they started, whether it was 319 or even as late as 4-3, we have a pretty strong spread of high number of COVID-19 cases, regardless of start date. The other thing that was surprising to me is that nobody started until after that fast exponential growth period. And then some states don't even have stay-at-home orders in place. So unfortunately, this didn't have a lot of correlation. Now, what this doesn't show is if it slowed the spread once they were put into place. And I didn't go into any further detail. That would be further study required. But what this did show is that, as I broke it out this way and started to look at some of these larger cases, that again, it's some of the larger states that are experiencing the high number of COVID-19 cases. So did the state population contribute to the spread of COVID-19? So I used a bubble chart to show each state. The size of the bubble indicates the state population, so larger, the more people. The number inside the bubble is the state's population, which I had the data mine for. And then I also had to link that data to the total number of cases for COVID-19. So I basically picked some of the redder, which is it's a heat. It's overlaid with a heat map. The deeper dark red shows more COVID-19 total cases. So interestingly, California being the biggest, they had a large number. Texas being the biggest had a large number. But let's look over here at like Massachusetts. Relatively small state in terms of population, but boy, they had a lot of cases. Connecticut, another one. Again, very relatively small population, but a relatively large amount of cases. New Jersey is another one. So when I laid it out this way, this was surprising, and now it's starting to look a little more regional to me. Is there a regional phenomenon going on here in terms of how the state's population or how the spread of COVID-19 was tracking through the continent? When I looked through this and I looked at some of the hotspots, Um, it was almost it was this was a eureka moment for me in the part of the project. It was actually surprising. I said, "There's some pretty large airports in some of these states. I wonder if there's a correlation." And so I used this, my hypothesis of population as I went down this path. I said, well, let's take a look at airport traffic. And sure enough, when I laid the total COVID-19 cases as a heat map on the United States, I overlaid and I had a data mine for airport traffic. And I think it was the 2018 top 30. That was what I was able to find for airport traffic. But I figured it was close enough for the purposes of the study. Sure enough, the bigger the airplane, the more airport traffic, and the deeper red the state, the more COVID-19 cases. It's pretty close to a 1-for-1, right? You have a large amount of airport traffic, a large number of cases. This explains Illinois. Why did Illinois pop up in the middle of nowhere, right? It's because of Chicago, O'Hare. New England, right? A lot of airport traffic. You got Atlanta, huge Delta hub, and 4 major airports here in Florida. Another one here down in Texas. It's not the whole story, but it sure does. It is compelling. Further investigation we needed. How did Washington escape the spread? Right? Something's going on there. Why are they not a deeper shade or have more total cases, especially when they were the first case? You got Denver, another big airport, Las Vegas, another big airport. So some of these states were able to mitigate the spread. It's interesting, and definitely further investigation would be required. And so finally, I was interested in this idea of flu or COVID-19. What was this a potential reason for the lag in that month of February, where I know personally in my workplace we had a higher absenteeism than we've seen in recent years, and it was very concerning. And what we were hearing is that it was diagnosed as flu, and so I thought this was a great project to investigate that further and really understand that 28-day lag that I observed in my initial research. So I was able to extract this data from the CDC, and I organized it as a bar chart. And now it's not conclusive, but there is some evidence. So I organized this by month buckets and then per year, and this is total flu cases. And again, I was able to get this from the CDC. And you can see here that sure enough, February has more total flu cases than prior years, by quite a few actually. Now it's not conclusive because you can see here 2018 flu cases were more in January. Total flu cases here in March of 2019 were more. However, it's an indicator. Maybe there is something more to this story where people who were diagnosed with flu really did have COVID-19. It's an indicator, but not absolute. So that wraps up my project and my findings. I really enjoyed this because of how relevant it was to what's going on. Thank you.